In this video, we're going to go over the changes of state, kinetic energy, and intermolecular forces. So kinetic energy versus intermolecular forces. States of matter differ in the amounts of kinetic energy, which depends on temperature. At a given temperature, all substances have the same average kinetic energy. Since at a given temperature, all substances have the same average kinetic energy, it's the strength of the intermolecular forces of attraction that determines whether a substance is a solid, liquid, or gas at that temperature. Solids have higher intermolecular forces of attraction than liquids. Liquids have higher intermolecular forces than gases. Intermolecular forces include dispersion forces, dipole-dipole forces, and hydrogen bonding forces. And they vary depending on the element or compound. During a change of state, intermolecular forces are disrupted or formed. Covalent bonds are not changed, and therefore a change of state is a physical change, not a chemical change. Melting occurs when melting from solid to liquid occurs when some intermolecular forces in the solid are disrupted. Vaporization, so from liquid to gas, occurs when all of the intermolecular forces between the molecules in a liquid are disrupted. Intermolecular forces are strongest in compounds that have hydrogen bonding, because hydrogen bonding is the strongest intermolecular force. Polar molecules containing oxygen-hydrogen, nitrogen-hydrogen, or hydrogen fluoride bonds have hydrogen bonds. So for example, ethanol is liquid at room temperature because the kinetic energy of the molecules is insufficient to break the strong hydrogen bonds between the ethanol molecules. Propane is a gas at room temperature because the same amount of kinetic energy is enough or is sufficient to break the weak dispersion forces between propane molecules. Propane does not have any oxygen-hydrogen bonds, therefore it does not have hydrogen bonding. It only has dispersion forces, which are weaker intermolecular forces than hydrogen bonds. Therefore, that's why it is a gas at room temperature, unlike ethanol, which is a liquid. Energy is transferred during a change of state. Heat energy is transferred to or from the surroundings in accordance with the first law of thermodynamics. So with vaporization, energy is transferred from the surroundings to the substance evaporating. So if you have liquid plus heat, it goes into vapor. This increases the kinetic energy of the liquid molecules, which breaks the intermolecular forces between them, and then the molecules enter the gas phase. Condensation is the opposite. So energy is transferred from substances to surroundings. So you have vapor and you take away heat and it turns into liquid. This decreases kinetic energy of gas molecules and it cools so that the intermolecular forces between molecules or atoms in the liquid phase can form. So it cools enough so that they can form, and then the molecules enter the liquid phase. Changes of state can be either endothermic or exothermic, so release or absorb energy. Endothermic, heat is absorbed from the surroundings. And the changes of state that are endothermic are melting, vaporization, and sublimation. Exothermic, heat is released to the surroundings. And the changes of state that are exothermic are freezing, condensation, and deposition. For the vaporization of water, as heat energy is added to the liquid, the kinetic energy of water molecules increases and temperature increases. Vaporization of water requires the addition of heat either through a stove or a hot plate. And in the gas phase, the molecules have a greater speed and negligible interactions between the molecules. And so they cannot reform those bonds. Faster moving water molecules with higher kinetic energy break away from the intermolecular forces that keep them in the liquid phase. Unique characteristic of gases is that they are also compressible, which means that the increasing pressure on a gas also causes a change of state from gas to liquid. When the valve on the oxygen cylinder is open, the oxygen is exposed to lower pressure of the atmosphere and expands to become a gas. People with compromised lung function are often required to carry supplemental oxygen, which is supplied by a cylinder of liquid oxygen. The heavy-walled cylinder is under pressure, and the oxygen in the tank is in the liquid phase. Oxygen stores as a compressed liquid because it occupies much less volume in the liquid phase than the gas phase. So in summary, compounds at the same temperature have the same amount of kinetic energy, and therefore the strength of the intermolecular forces between molecules determines the state of matter for a substance at a given temperature. Polar molecules have stronger intermolecular forces than nonpolar molecules. Heat energy is transferred to or from the surroundings during a change of state. Melting, vaporization, and sublimation are endothermic physical changes, while freezing, condensation, and deposition are exothermic. And due to compressibility of gases, they can be liquefied by the application of pressure.